Welcome to session 2 of the summer supplement. This session is going to be devoted to adding and subtracting rational expressions. In the last lesson we talked a lot about simplifying the rational expressions when they were multiplied or divided. We need to review a little bit about rational numbers or fractions, because rational algebraic expressions will use the same rules when you add them as regular plain old fractions. I know that many of you have learned to do this on your calculator as far as adding and subtracting fractions. However, you're going to have to remember some of the old ideas in order to be able to do that with rational expressions. Keep in mind that rational algebraic expressions do use those same rules as regular fractions. And when you're adding or subtracting regular fractions, you have to use common denominators before you can add them or subtract them. Rational expressions using variables have to use those same rules regarding the common denominators. So we're going to backtrack a little bit to review how to add fractions manually. This should seem very familiar to you. And then we're going to move on as far as what we need to do for dealing with the rational expressions that have algebra problems in them. Okay, first reviewing the process of adding fractions. If we wanted to add 3/5 and 5/7, you'd find the least common denominator. You can find that by multiplying these two denominators. Since there's nothing in common, we'd have a 5 times a 7, 35, the least common denominator. As I said, this should be nothing new to you, just reviewing a little bit for you. We need to rewrite each fraction in terms of the common denominator. And when we did that, we'd find that we needed to multiply this numerator and denominator by 7, getting 21/35, and this numerator and denominator by 5, giving you 25/35. Once you have common denominators, you would be able to add up the numerators. And once you add the numerators, you have a fraction. You would always check to see if it can be reduced. This one in particular can't be reduced. However, you should always check. We need to keep that in mind also when we start dealing with the rational algebraic expressions, to see if those fractions can be reduced as well. Alright, let's check here and take a look at another one. Once again, I know that this is review, but you've really got to be strong on adding regular fractions before we can even begin to talk about the algebraic rational expressions. So finding the least common denominator, I might be looking at it a slightly different way than the way that you looked at it before, but this is going to help you with our next concept. So you need to take a look at the factored form of the denominators. So 10 would be 5 times 2, and 4 would be 2 times 2. Okay. When you're finding the least common denominator, you take everything from the first denominator and you multiply it times whatever the second fraction has that the first one doesn't have. So for example, 2 times 5 is everything from the first fraction. The second one has a 2 that the first one doesn't have, so you have to multiply that in there too, and that gives you the least common denominator. You may not have thought of it in exactly those terms before, but when we think of it that way, it's going to make your rational expressions work that much easier. You could probably have just looked at it and said, okay, the common denominator is 20, but I wanted to review the process so that you would be it would be easier for you to be able to do the next type of problems. So once again, as I said, this is review. In order to get that least common denominator, this one needed the extra 2, so multiply numerator and denominator by 2. This one needed the extra 5, so multiply numerator and denominator by 5, giving you 6/20 plus 15/20, total of 21/20. As always, we check to see if it can be reduced, and this one can't. All right, now that we've had a quick review of how to add regular fractions, let's move on to our rational expressions. All right, here's an example. 2x over 5ab cubed plus 4y over 3a squared b squared. So we need to take a look at these denominators, thinking of them in terms of their factors. This denominator has factors of 5 times a times b times b times b. This one has 3 times a times b times b. So what we need to do is begin to find the least common denominator. Remember, we said we always start with everything from the denominator of the first fraction. Everything from the denominator of the first fraction, 5a, b, b, b. Then we have to figure out what the second one has in its denominator that the first one does not. So we take a look through, and we see that this one has a 3 and this doesn't have a 3. So we're going to bring a 3 over. This one has 2 a's, whereas this one only has 1. So it's going to need an extra 1. This one has 2 b's, but we already have 3 b's accounted for, so we don't need to put in any extra b's. So 3a is what the second fraction has that the first one does not. So when we go ahead and multiply that out, our least common denominator is 15a squared b cubed. So that's the common denominator we are going to need to have for these fractions, these rational algebraic expressions, in order to be able to add them. We need to be able to use that common denominator. There it is again. So just like in the regular plain old fractions, we are going to need to multiply the numerator and denominator so that each fraction has a common denominator. So we need to figure out on this particular part, what does this need to make this as its common denominator? We see that it needs an extra 3 and it needs an extra a. So we would multiply the numerator and the denominator by 3a. 3a, 3a. That'll give us 15a squared b cubed in the denominator here. And you can always multiply numerator and denominator by the same thing. It's really nothing more than multiplying the whole expression by 1, so it doesn't change its value. But what it does do is it allows you to be able to put these two together. Now notice I wrote this out with a blank here. We have to figure out, what do we need here to multiply to get our least common denominator? Well, we need to have a 15, so we'll need to multiply this by 5. The a squared is taken care of, but we need another b. So therefore we need to multiply the numerator and denominator by 5b. There it is, 5b, 5b. This will also give us 15a squared b cubed, which is our common denominator that we're looking for. Now after we do this, we need to simplify before we can go ahead and add. So we'll clean this up a little bit. This will be 6ax, this will be 20by, and we'll simplify that denominator. 6ax, 20by, there are our common denominators. 15, a squared b cubed. Now, just like with any other fraction, after you have the common denominators, all you really need to do is add up those numerators and make it one fraction that has the denominator that you just found. 6ax plus 20by over 5a squared b to the third. Don't forget, we should always check to see if there is any way to reduce the final answer. Now in this case, if we tried to factor this, we could pull out a 2, but since we can't pull out a 2 in the denominator, there's nothing in common that's going to be helpful for reducing this fraction. There's not an a in both, there's not an x in both, a 3 can be brought out of this one but not here, so there's nothing that you're going to be able to bring out of both of these terms so that you can cancel. So this answer is complete at this point, but I don't want to neglect that you should always check to see if it can be reduced. Many times they can actually be reduced. Okay, if the denominators are not in factored form, you're going to need to factor before you can find the least common denominator, or at least ask the question, what does each fraction have in its denominator that the other one does not? The one that we did previously uses the second thing. We asked, what does each fraction have in the denominator that the other didn't? In this case here, we will need to factor to be able to find them. So let's take a look at another example. Now here we have two denominators, and those denominators are going to have to be put into their factored form before we can do anything about adding them. Now, if you remember, you would check to see what is it that you can multiply together here to get this 6, that when you add them you'll get 5. 2 times 3 fits that bill, so that's going to help you with that factoring. What can you multiply together to get 4, so that when you add it you also get 4, and 2 will work in that case. So here's our factored form. If you need to recall a little bit more about factoring, we did do quite a bit of that in the last section, the last lesson. So you should look back into that, or you can always go back to the Algebra 2 notes and check on those things to review your factoring if you need to do that. So let's move on to what we're doing here. We're looking for least common denominator. Remember, we said we always start with the denominator of the first fraction. So we have to have an x plus 2 times an x plus 3 in the denominator of both. Then we look at the second one and we put in here whatever is found over here that is not found over here. Now, yes, there is an x plus 2 found over here, but there's an extra one here. So we have to make sure that our new denominator has 2 of them, just like this one does. So whatever the second has that the first does not, we need an extra x plus 2. So our least common denominator has to have 2 factors of x plus 2 and 1 factor of x plus 3. Now, what we need to do then is figure out what extra does this one need in order to get that common denominator. What extra does this one need in order to get that common denominator? It needs an extra x plus 2. So we're going to multiply numerator and denominator here by x plus 2. what does this one need? That's right, it needs an extra x plus 3. So we're going to multiply this one by x plus 3 over x plus 3. And there they are. So as I was saying, this one needs an x plus 2 over x plus 2. This one needs an x plus 3 over x plus 3 in order for the denominators to both have two x plus 2's and an x plus 3. Alright, now we need to do some simplifying. This x needs to be multiplied here. This 2 needs to be multiplied here. Now I'm not going to do anything about simplifying the denominator yet, though. I'm going to leave that in factored form just in case we need to reduce it later on. Okay, so here's our x. Once we distribute it to x plus 2, we get x squared plus 2x. And here when we distribute our 2, we get 2x plus 6. That's a hello from my dog. Then when we rewrite this, we need to keep in mind that this minus here applies to both the 2x and the plus 6. So we're going to be subtracting both of those. X squared plus 2x minus 2x minus 6. And they're gathered then over the same denominator. That's the whole reason that we do common denominators in the first place. Right. So we then simplify a little bit. Notice that the 2x minus 2x will cancel out. We'll get x squared minus 6. If we try to factor this, it is not the difference of two squares. There's nothing that you're going to be able to do to simplify x squared minus 6. So there is nothing that can cancel here, but you do not have to multiply this all out in order to finish up. You can go ahead and leave that in its factored form, and this is just perfectly fine to leave as your answer like that. Okay? Now there's some other things that can possibly happen, so we're going to take a look at another example. Okay. Once again, the denominators are not in factored form, so we're going to go ahead and factor them. This one looks like it's a little bit easier, so we can pull a 2 out of this one, and we can pull a 4 out of this one. So this becomes 2 times x minus 3, and this will become 4 times x minus 3. Just rewrote the numerators. 2 times x minus 3, 4 times x minus 3. Now our least common denominator here, actually the only thing that's needed here is this fraction needs an extra 2. So our least common denominator is really 4 times x minus 3. Since this one just needs an extra 2, we're going to multiply numerator and denominator by 2. Numerator and denominator by 2. Leave this one alone. This will give us a 4 down here and make it match this denominator. So we need to simplify this. So we're going to distribute 2 times x minus 10. Then we're going to do a minus x minus 7. I chose to do parentheses here so that we do not lose any of the negatives or forget to change anything over. And this is still 4 times x minus 3. I'm leaving it in its factored form here, although I did put the 2 and 2 together to get 4. So when we simplify this just a little bit further, this changes to minus x, this changes to plus 7. Then we begin to put the pieces together. 2x minus x is x. Negative 10 plus 7 is negative 3. So we end up with x minus 3 here. Now here's where the interesting part is. We need to look for things to cancel. You probably noticed that these look the same. There is technically parentheses here. It is a grouping symbol. But I don't want you to miss out on the fact that that doesn't leave a 0 in the numerator it actually leaves you with a number. And if we look at this in its factored form, we'll be able to see it. Remember, 1 is a factor of anything. So this numerator is really 1 times x minus 3. Once you recognize that, once again, we can cancel the x minus 3 and the x minus 3, and it leaves you with 1/4. And that is your final answer to this problem. As unsimple as this looked, it does simplify down to just a simple answer of 1/4. Now, we did talk in the last section about there being some exclusions. X would not be allowed to be 3. Just kind of tuck that in the back of your mind. This does simplify to 1/4 as long as x isn't 3. That'll become more important when we get into lesson 3. But for right now, just tuck it in the back of your mind. All right, let's take a look at another example having to do with complex fractions. Complex fractions can also include addition or subtraction. This one happens to include both. Complex fraction because you have a fraction over a fraction. So when you begin to solve these problems, you need to look at them in terms of the numerator and the denominator being their own problem. Treat the numerator and denominator as their own problems before you begin to move on. So in other words, I look at this numerator and say, well, the common denominator here is going to have to be 3. So I'll have to multiply this times 3 and this times 3. The common denominator down here is going to be 6. So I'll be multiplying this by 6/6. There's what that looks like. Common denominator 3, common denominator 6, and then we can put those things together. 3x plus x is 4x over 3. 6x minus x is 5x over 6. After you've done that simplifying step, that's when we can deal with the complex fraction. So we rewrite, because this really means divided by. Rewrite it. Then you need to recall that the divided by for a fraction means that you multiply times the reciprocal. Then we need to remember that the next thing we can do is cancel. So we'll cancel those out. 1 and 2. X's cancel. And what we're left with is 4 times 2 is 8 over 1 times 5, which is 5. So this whole complex fraction here reduces down to 8/5. Now at this point, I'm going to stop this portion of lesson 2, and you'll log back on and take a look at part 2 of lesson 2 a little bit later, and then you're going to make sure that you complete all of the problems that go along with it.